In section 11.2, we discussed the topic of electrolytes. And electrolytes are simply solutions that are able to conduct an electrical current. So previously, we had considered what happens when an ionic compound dissolves in water. And what we said happened was that polar water molecules interact strongly with ions at the surface of a crystal and pull those ions out of the crystal and into the solution. So basically what happens is that the attractive forces between water molecules and the ions overcome the forces between the oppositely charged ions in the crystal, and the ionic compound dissolves. This type of interaction is referred to as an ion-dipole interaction. The negative end of the dipole of a water molecule is attracted to cations, and the positive end of the dipole of a water molecule is attracted to anions. These types of interactions have a high energy. They can be several hundred kilojoules per mole, which is similar in strength to a covalent bond. As a result, if several of these occur between one ion and multiple water molecules, then the water is able to break the strong ion-ion interactions that hold the crystal together. Now, what this is really telling us is that when ionic compounds are dissolved in water to form aqueous solutions, what is present in that aqueous solution are individual cations and anions completely dissociated from one another. So as a result, solutions of ionic substances when they're dissolved in water are described as electrolytes, as the cations and the anions are able to carry an electric charge, and these solutions will be observed to conduct electricity. So if we take some distilled water and we measure its conductivity, we will find that it is non-conducting because there are no charged particles present. There's nothing to carry the electrical charge. If we repeat the experiment using a solid ionic compound, say something like salt, we'll find that solid salt also does not conduct electricity because the ions are locked in place in the crystal and unable to move. However, if we add the water to the salt and create an aqueous solution, then we'll find that that aqueous solution will conduct. And the reason it can conduct is because we now have mobile cations and anions. And the cations can move towards the negative electrode, the anions can move towards the positive electrode, and the net result is that this solution will conduct an electric current. Now, not all, but many covalent compounds are also soluble in water. A good example of this is ethanol. Ethanol is the kind of alcohol that gets you drunk, and it's commonly sold as an aqueous solution. Most covalent compounds do not dissociate into ions when they're dissolved in water, but rather remain as intact neutral molecules. And for this reason, we'll find that for most covalent compounds, their aqueous solutions are non-electrolytes and do not conduct electricity. However, there is an exception. Acids do function as electrolytes. In particular, aqueous solutions of strong acids are good electrolytes as they completely dissociate into ions in aqueous solution. So a strong acid, like hydrochloric acid, is defined as a substance that when dissolved in water completely dissociates into hydrogen ions and an anion. So, same as for the solution of the ionic compound, we have completely dissociated ions present in the solution of a strong acid, and as a result, strong acids, their aqueous solutions are good electrolytes. So acids are an exception to the rule that covalent compounds are non-electrolytes. Now, of course, in addition to there being strong acids, there are weak acids. And weak acids, such as acetic acid, the acidic component in vinegar, are weak electrolytes. They don't conduct electricity particularly well, and the reason for this is because they only partially dissociate in aqueous solution. So weak acids don't completely fall apart into hydrogen ions and an anion. In fact, most of their molecules remain intact as neutral molecules, and as a result, aqueous solutions of weak acids are conductors but not great conductors of electricity, so we describe them as weak or poor electrolytes. Okay, so that concludes section 11.2 on the topic of electrolytes.